I request all the dignitaries to please adore the seats on the dais. I request Smita Acharya ma'am and Belgamar ma'am to escort the dignitaries on the dais. For this prestigious program, we have with us President of Program, Honorable Dr. Subhash Chaudhary, Vice Chancellor RTM Nagpur University. Chief guest and keynote speaker, Dr. Vasant Sathe, Center Director UGC DAE Consortium for Scientific Research Indore. Professor Rajesh Singh, Director Innovation Incubation Linkages, RTM Nagpur University. Professor Smita Acharya, Professor Department of Physics and Director Internal Quality Assurance Cell, RTM Nagpur University. Professor Pramod Khedekar, Head of the Department, Department of Pharmaceutical Sciences. Professor Veena Belgamwar, Coordinator of National Science Day Program. And Dr. Vijay Tangde, Co-Coordinator of National Science Day Program. On behalf of Organizing Committee, it's my pleasure to welcome all the dignitaries, special invitees, head of the departments, faculty members of various departments, and dear students for the inauguration ceremony of National Science Day 2022, being organized by Innovation Incubation Linkages and Internal Quality Assurance Cell, RTM Nagpur University. As per our tradition, I request all to rise up for Vidyapit Geet. Offering prayers to Almighty, we are having our customary lamp lighting ceremony for seeking the choicest blessings of God. I request all the dignitaries on the dais to inaugurate the function by lighting the traditional lamp and offering flowers to Devi Saraswati, Tukdoji Maharaj, and our respected late Dr. A.K. Dorle sir.
पद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा। शुक्लां ब्रह्मविचारसारपरमां आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहाम्। हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्।
Here we also have our Dean of Faculty of Science and Technology, Professor Prashant Maheshwari sir. As a customary tradition, we would like to proceed for the floral welcome of our distinguished guest. May I request Rajesh Singh sir to welcome President of today's program, Honorable Dr. Subhash Chaudhary, Vice Chancellor, RTM Nagpur University, by presenting a sapling and memento. Here I would like to mention that this startup idea competition theme. Here I would like to mention that this startup idea competition theme has been taken in latter end spirit by the incubation center of our own university by making the memento of the event using 3D printing technology. And the lead of this has been taken by Dr. Abhay Deshmukh, who is heading this center. So I request the gathering to give a big round of applause for the center. Now I request Smita Acharya ma'am to welcome our Dean, Faculty of Science and Technology, Dr. Maheshwari sir, by presenting a sapling. I welcome Chief Guest and Keynote Speaker, Shri Vasant Sathe, Center Director. Sir is not present online. Sagar. I welcome Chief Guest and Keynote Speaker, Shri Vasant Sathe, Center Director, UGC DAE Consortium for Scientific Research, Indore, who has joined on online platform.
Thank you. Thank you very much.
Welcome, sir. May I request Professor Smita Acharya ma'am to welcome Professor Rajesh Singh, Director, Innovation, Incubation, Linkages, RTM Nagpur University, by presenting a sapling. I request Professor Veena Belgamwar to welcome Professor Smita Acharya, Director, IQAC, RTM Nagpur University, by presenting a sapling. I request Dr. Vijay Tangde, Co-Coordinator of Program, to welcome Professor Pramod Khedekar, Head of the Department of Pharmaceutical Sciences, RTM Nagpur University. I request Shanware ma'am to welcome Professor Veena Belgamwar, coordinator of NSD 2022, by presenting a sapling. I request Kadam sir to welcome Vijay Tangde sir, co-coordinator of National Science Day program, by presenting a sapling. Science is organized knowledge. Wisdom is organized life. 28th February is celebrated as National Science Day in India since 1928. This day is celebrated to mark the discovery of the Raman effect by Sir C.V. Raman. For the discovery, he was also awarded with Nobel Prize in Physics in 1930. The main objective of National Science Day is to bring awareness to people about the importance of science in our daily life and to encourage people by popularizing science and technology. Every year, the day is celebrated with a particular theme. The theme for this year's celebration is Integrated Approach in Science and Technology for a Sustainable Future. On this occasion, various competitions are organized today. These are Startup Idea Competition and Self-Designed Product Advertising Competition, cum exhibition and auction sale. This year, for the first time, we have introduced one new concept, that is interdepartmental exhibition competition to exhibit or display their best practices, their academics, research, unique achievements, activities of departments, etc. The department having best practices will be felicitated. Now I request Dr. Veena Belgamwar ma'am for the introductory remarks.
Thank you, Dr. Rita Vartma, ma'am. On behalf of Rashtrasanta Tukadoji Maharaj, Nagpur University, I extend my warm welcome to all the dignitaries, faculty members, and my fellow students. Every year, we celebrate February 28th to mark the invention of Raman effect. National Science Day promotes science and technology and its feasibility in our daily life. It also encourages scientists, writers, students, and others who are involved in the promotion of science and technology. The day must be observed with the same diligence every year. I think it should not be limited only to the science fraternity, but also to the participants from various walks of life. Science that stands for systematic, comprehensive investigation and exploration of natural causes effect has given a whole new meaning to our life. This year, National Science Day has theme Integrated Approach in Science and Technology for a Sustainable Future as its theme. NSD 2022 is marked to raise awareness about the importance of science in people's daily lives and to recognize all the activities, projects, and achievements in the field of technology that help humanity. It is commemorated by implementing new technologies for scientific growth, providing opportunities for scientifically inclined individuals in India, encouraging and popularizing technology and science. It is said that the science of today is the technology of tomorrow. I'm sure that it hasn't skipped anybody's notice how the science and technology has become part and parcel of our lives. We find the wonders of science wherever we look. Robots, autonomous vehicles, smart devices, digital currency are all the gifts of science. E-gadgets has brought the entire globe at our fingertips. On the other hand, the internet has made a remarkable change in the field of communication and information technology as well. The development of medical science has lengthened our lives. Keeping all this in mind, let us all pay our respects by contributing to this transformation. I would like to allude that pertaining to this year's theme, Rashtrasanta Tukdoji Maharaj Nagpur University has organized 2 competitions. One of them is a startup idea video presentation competition, while the other being self-designed product advertising competition. Once again, I welcome you all and wish all the best to the participants. Thank you once again. Thank you.
Thank you, ma'am. Now I request Dr. Smita Acharya ma'am to highlight R&D activities of RTM Nagpur University and introduce the chief guest and keynote speaker, Dr. Vasant Sathe sir. Please, ma'am.
Thank you, Veena. Good morning to one and all present here. Dignitaries on the dais, Honorable Vice Chancellor Sir, Dr. Subhash Chaudhary, President of this function, Dr. Vasant Sathe, Director, UGC DAE CSR Indore, Center Chief, the guest of honor for this program, Dr. Rajesh Singh, Director IIL, Dr. Pramod Khedekar, HOD, Department of Pharmaceutical Science, Dr. Prashant Maheshwari Sir, Dean, Science and Technology, Dr. Veena Belgamwar, Dr. Tangde Sir, all Deans, Director, Head of various PGTD departments, all my colleagues, dear students, ladies and gentlemen. I welcome you all in NSD 2022. The national theme of NSD 2022 is Integrated Approach of Science and Technology for a Sustainable Future. Dear friends, we all have experienced this integrated science and technology approach in pandemic crisis. In every level, science and technology combinedly work for the survival of humanities. And now it is a high time to sustain this spirit and push the integrative approach to face challenges arises worldwide after post-pandemic era. Okay. On this special occasion, I will take a privilege to introduce last academic year achievements of RTM Nagpur University, especially in research and development, even though all world is facing all barrier due to pandemic crisis. University maintained NAC A grade in revised NAC framework. This is a big achievement. Then I feel proud to share with you that in 1 year, RTMNU have published 34 patents, out of which 19 are granted and till date 2 are commercialized. And major contribution for this is pharmaceutical department, physics department, and few department of LIT. So please give a big round of applause for this. In last 1 year, 10 sponsored research project having fund around 3 crore has been awarded to the university. Our university have signed 7 MOUs with establishing 56 research collaborations with different national and international academic and research institutes. Overall, in last year, 158 research publication, especially in international journal, Scopus and Web of Science publications. This is data we collected from Web of Science and Scopus directly. 3 researchers of university has been honored as a fellow of Maharashtra Academy of Science. I want to specially mention their name, Dr. Sanjay Dhoble from Department of Physics, Dr. Banavse from LIT, and Dr. Smita Acharya from Department of Physics. Again, I will feel proud to mention here that 2 professors of RTMNU are listed in top 2% scientists having highest publication as per list published by Stanford University, USA. I would like to specially mention their name again, Dr. S.J. Doble from Department of Physics and Dr. Bhanose from Department of LIT. Okay. So RTMNU is emerging as a high potential university in research and development. I congratulate all the research team of RTMNU for this success. Okay. Now, I have given the second responsibility to read the brief introduction of our today's chief guest, Dr. Vasanta Sate. He is a good collaborator of RTM Nagpur University. Many collaborative projects with RTM Nagpur University is with Vasanta Sate sir. So I would like to introduce him to all the RTMNU team and all the participant present here. Dr. Vasant Sate just had taken the charge of Director UGC DAE CSR Indore Center. His research interest is mostly in Raman spectroscopy and all the experiments, advanced experiments related to Raman scattering. Then his experimentation expertise in X-ray absorption spectroscopy, X-ray and neutron diffraction, epitaxial thin film growth. He had published more than 250 plus research publication in international journal. Very recently, he is honored with very prestigious Material Research Society of India Medal 2021 award. He is the Biocost Fellowship of Department of Science and Technology India, ICTP Fellowship for working on the Synchrotron Center Italy. His best thesis presentation award in DAE Symposium on Solid-State Physics. And his research work is highly highlighted in Institute of Physics, especially the femtometer scale displacement in single crystal and epitaxial film in complex oxide system. That work is highly highlighted. He has invented a protocol to trace femtometer scale. Here for the student, I want to mention you that femtometer is 10 to the power minus 15. It's very small as the atomic dimension also. Okay, and that his research contributed very high impact to interpret scientific phenomena in development of advanced technology. So I feel that he is a perfect person to speak on the theme of today's Science Day program, that integrated science and technology, because his basic research is highly applied in development of advanced technology and nanotechnology. Now, briefly, I want to introduce what is the UGC DAE CSR. The consortium, UGC DAE CSR consortium, works for augmentation and enrichment of scientific research in Indian university and education institutions of higher learning. The synergy of UGC and DAE in the form of UGC DAE Consortium for Scientific Research is providing high-end mega science research facilities of the DAE to Indian research communication. And now Dr. Vasanta Sate sir is the director. So we hope that there is a good bond is created between RTM Nagpur University and UGC DAE CSR. Now currently only 2 projects are running in collaboration with UGC DAE CSR. We hope that in next Science Day, more than 50 collaborative projects of RTMNU with UGC DAE CSR will be collaborated under the leadership of Dr. Vasanta Sate sir. So, thank you very much for giving me this opportunity.
Thank you, Smita ma'am. Now I request Dr. Vasant Sate sir to deliver the keynote address.
नमस्कार. माझा आवाज ऐकू येतोय नीट?
हो सर, अगदी क्लिअर आहे.
सर्वप्रथम मी तुकडोजी महाराजांना नमन करतो, आदरांजली वाहतो. स्टेजवर बसलेले सगळे आदरणीय ऑनरेबल व्हाईस चान्सलर यांना नमस्कार करतो. बाकीचे जे सन्माननीय प्रोफेसर आणि गुरुजन आहेत त्यांनाही नमस्कार करतो. आणि सगळ्यात आधी एक क्लॅरिफिकेशन देतो की मी इंदोर सेंटरचा सेंटर डायरेक्टर आहे, UGC DAE CSRचा डायरेक्टर नाही. मला आठवतं एका मुलाखतीमध्ये गडकरींना विचारलं होतं, का हो तुम्ही कधी प्रधानमंत्री बनताय, कधी प्रधानमंत्री बनताय? तर गडकरी हसून म्हणाले होते, तुम्ही सारखं असं मला विचारलं तर मी मंत्री सुद्धा राहणारच नाही. तशी स्थिती बहुतेक माझी सुद्धा होणार आहे, कारण आमचे डायरेक्टर सन्माननीय प्रोफेसर अमलान पाल आहेत, जे की IICS कोलकातामध्ये ह्याच्या आधी म्हणजे अजूनही त्यांची पोझिशन तिथे आहे, प्रोफेसर आहेत आणि सेमीकंडक्टरवरती रिसर्च करतात. आमचे 3 सेंटर्स आहेत, एक इंदोरला ज्याचा सेंटर डायरेक्टर मी आहे, मग दुसरं मुंबईला ज्याचे डॉक्टर बाबू सेंटर डायरेक्टर आहेत, आणि एक कलकत्त्याला आहे VCC जिथे आहे म्हणूनसाठी, आणि त्याचे डॉक्टर घुगरे म्हणूनसाठी डायरेक्टर आहे, आणि आमचा एक नोड कल्पकमला सुद्धा आहे. तर तुमच्या जे जवळ पडेल त्या सेंटरला तुम्ही व्हिजिट करू शकता, आणि प्रोजेक्ट कोलॅबरेशन डायरेक्ट नसलं तरी आमच्या सगळ्या फॅसिलिटीज ज्या आहेत सगळ्या युनिव्हर्सिटीजच्या सगळ्या रिसर्च स्कॉलरसाठी फ्री ऑफ कॉस्ट उपलब्ध आहे. ही माहिती मी सगळ्यात आधी इथे देऊ इच्छितो. तर तुम्हाला प्रोजेक्ट तुम्हाला लिहायचा असेल तर लिहा, नसेल लिहायचं तर नसेल लिहा, पण तुम्हाला जर का आमच्या एक्सपेरिमेंटल फॅसिलिटीज यूज करायच्या असल्या आणि तुमच्याकडे चांगल्या आयडियाज असल्या तर तुम्ही एक्सपेरिमेंटल फॅसिलिटीज आमच्या कधीही येऊन यूज करू शकता, वापरू शकता. ऑफकोर्स आजकाल बिकॉज नाउ this center has been very widely advertised, so there is a fierce competition among many of the people, and you will get the time depending on the quality of your proposal. So first of all, let me again thank Professor Smita Acharya for giving this opportunity to me and sharing some of the thoughts with the students over here, young students over here. I believe Raman spectroscopy or the discovery of Raman spectroscopy was fundamentally taken as a science day because Raman has not shown only the scientific acumen, but he was also very confident scientist, which is what is required for today's theme of yours, which is for a sustainable future and for startups. Because in startups also you require enormous confidence, and of course in putting up your ideas, because most of the students when I interact, they even are shy of putting their questions. So if you have to put ideas, you really require a lot of confidence. So I'm really happy for this particular theme on Science Day. So I will start my lecture because I don't want to showcase my results only, that anyway I am going to showcase in the end, but because I believe that there are diverse students of diverse interest are present in this august auditorium. So what I will do is I will take you to the journey of the life of discovery of Raman spectroscopy. It's a popular lecture which I would always like to deliver in front of the students, and then I will show you results, and if you are interested, I am always eager and ready to answer your questions and queries which you will present. So I will definitely show some of the slides where I will show that this discovery has marked so much nowadays, and it is so important nowadays, particularly in nano field, carbon nanotubes, graphene and all other things. Raman is a very important thing. So let us go on to see what Raman has done and what is the contribution of Raman in Indian science. Because see, confidence is very important. That is number one. And because in science, you may be sometimes wrong, you may be sometimes right, but you should be honest enough to share that, yes, that time you were right, now I am right, and putting up your ideas boldly and discuss with many people. And that is what Raman has done. See, Raman was, as you all may be knowing, that Raman was selected in Indian, that time it was called ICS, now it is equivalent to IAS. So he was working as an accountant in Kolkata. That is why he went to Kolkata. But he was graduated and post-graduated in the science, or that time it was called Master of Arts only. MA degree was given to even science students at that particular time. So just see that this particular gentleman, who was on a prestigious position of equivalent to even ICS, was considered more than today's IAS, because very few Indian students could clear ICS at that particular time. So he was a ICS and almost having all sort of a thing. So he used to go by tram, and accidentally he found that there was a board which is nothing but cultivation of science. So Mahendra Sirkar was the person who actually established this particular center. And so C.V. Raman just got down on one particular fine day and knocked that particular door. And to his surprise, he found that there is a big hall and there was no activities over there. the nephew of Mahendra Sirkar then asked him, what is your interest? Then he said that I have done my graduation and post-graduation in science, and I would like to do something science. And this board has attracted me, cultivation of science. So that is why I have approached you. So the nephew was in tears. He said that after establishing this center, after 10 or 15 years, somebody has come who has shown really the scientific temperament or really eager to do science. Then he asked, what do you do? And he explained that I am an ICS and I have to go regularly to the office from, let us say, 10 to 5 or something like that. And Raman was so Raman was so keen in doing science that during his MA degree itself, he was doing molecular scattering. So in molecular scattering itself, what he did is he did some research as a project student over there and published it in Philosophical Magazine, a very prestigious journal at that particular time. Believe me, 90 years ago, there were very few publications or journals which are present. Nature, Philosophical Magazines, and things like that were one of them. So Raman was very keen in scattering of the molecules in that particular part. And then Raman started his approach. He used to start his day by 5:30 or 6 in the morning. He used to reach the cultivation of science, work there by 9:30, come back, eat his whatever breakfast or something, and rush back to the office. Used to work there tirelessly till 5 o'clock. 5 o'clock he used to come back to the cultivation of science, and then used to again do science up to 9 in the evening, and then used to go back. Such a hectic schedule he was following for nearly 7 or 8 years of his first tenure in Kolkata. Later on, he was offered a lecturership or professorship in the Kolkata University or Presidency College at that particular time. So he resigned this particular post, which was a very prestigious post, and even he lost. He was that time offered 1,000 rupees per month as an ICS, and some 500 or 600 rupees was the salary of a lecturer or professor at that particular time. So even he discounted for that, and he never minded for that, because he thought that once I become lecturer or professor at this particular university, I will get enormous time to do science. And that is the reason that this particular day in his honor is celebrated as a science day. So let us go back to the discovery of Raman effect. See, in a Raman effect, what happens? Raman effect, we all know, is nothing but inelastically scattered light should be there. That is, if I have a green light which is shine on any liquid, solid, or a gas, then the scattered light has to be what? Has to be of slightly different color. It can be red, it can be blue, or any other color. So why this is happening? Raman was seeing this particular effect for nearly 4 or 5 years or something like that. And as we all know that as soon as Raman, that particular time, quantum mechanics was not fully developed. Okay, so people were even suspicious about the model of the Bohr. Bohr put a model that atom is round, electron is spinning around nucleus and things like that. But people were even suspicious about that, and were not ready to believe that. That is why Raman, in his first paper also published modified scattering. That is, he was not ready, or people were not ready to accept that a light can change its energy when interacting with a material. But Raman was a very keen person. See, what Raman did was, Raman was an eager reader also, and that is what is interesting, or we all researchers should learn from Raman, that not only his own work, but he used to read others' work and take clue from that particular point. Some 8 or 10 years ago, this was shown in liquids. We all know that a liquid is what? A liquid will scatter light, isn't it? But a transparent liquid, why it is not scattering? May I ask a question to the students? If you take a very pure liquid, that is a very pure water, the distilled water or something, then it is very transparent, isn't it? While as if you take a tap water, I don't know what is the position in Nagpur, but in Indore, if you take a tap water, there is a lot of scattering. Why that is happening? That is happening because in a tap water, we all know that there are impurities, isn't it? There are impurities, and that is what TDS, we typically nowadays with a RO system which is coming up, everybody knows that how much is the TDS. So this is TDS is nothing but number of particles which are present over there. So if I take a very pure liquid, then it is perfectly transparent. That is, the scattering is very minimum. While as if I take a slightly impure liquid, that is even water or any other particular form of it, then it scatters a lot. What is scattering? We all know scattering is nothing but the person or the element or the photon has to change its path. So scattering is of two types. Like scattering, if we see, then we can see that scattering can be what? It can be elastic scattering or it can be inelastic scattering. So in a scattering, what happens? A photon comes, interacts with that particular molecule and then goes away. So this scattering is minimum. When this scattering will be minimum? We all know because we travel in cities and somewhere here. So if the density of that particular liquid is constant, that is, there is no change in density which is appearing in that particular liquid, then scattering will be minimum. Same thing happens in our daily life also. We walk onto the street. If the density of the if it is a four-lane road, then even if there is a lot of traffic also, we don't have any scattering. While as if it is a single road, even with some minimum traffic also, we have to scatter. That is, we have to change our path. So this is the point which has been elaborated by Einstein and Smoluchowski. Smoluchowski is a Russian scientist. Both of them independently found out that when there is a second order transition or even first order transition generally, so a liquid transforming to any other liquid or to, like in water, if you freeze it, it will go from gas to liquid, and from liquid to what? It will go to ice. Okay, so it is going from liquid to the solid. So they found that during any phase transition, not necessarily liquid to solid or something like that, to any phase transition which is appearing over there, there is a large amount of scattering which is taking place. I believe you all must have studied it in your graduation, and it is called critical opalescence. Okay, so why this is happening? Again, if you see, why in a clear glass, if you see, there is no scattering. That is why we are unable to see. It is my specs, if you see. I am able to see through this because there is no scattering. If the light starts scattering, if it is coming and getting scattered, it will not go to my eyes. So I will not be able to see. So this scattering is minimum in glasses because the density is nearly uniform over there. So if there is any uniformity into the material, that is the density is uniform, then there will be hardly any scattering that is going to take place. And this we can very easily understand, isn't it? If we take interference effects, we all know that there is a what? Constructive interference and destructive interference. So if the density of the material is even over all everywhere, then what will happen? Then I will always find a component which is destructively interfering with it. That is the phase difference between this photon which is getting scattered from one point of that particular point and other point of that particular point is going to get scattered in a destructive manner. So there is always, you can find this type of element, and if surface to volume ratio is very large, then we will find that this density, if it is uniform, there is no scattering. And that is what Raman has issued his instructions to the students. He said, you take a sunlight. So that time, how he did the experiment, he used the sunlight. That is the beauty of his this thing, that in any spectroscopy, we all know there are three typical elements which we will require. That is, the first is a source. The second is a dispersive element. Why I am saying dispersive element? Whether you take a prism or you take a grating or anything, what it does, it disperses the wavelength or it disperses the frequency. Both are inversely proportional to each other in space. That is why these are called dispersive elements. It is dispersing thing in space. And the third is detector. So Raman used two things as a natural thing. Okay, of course, collimator, filters, and other things are required for the things. But if out of these three basic elements, Raman used two elements which were naturally available. The first one is, of course, the sun. Sun as a very source. That time he never had anything else than sun. So he himself has designed a helistat, which is nowadays has been used very frequently in solar applications. We all know solar cells. So if the these panels are pointing towards suns, the efficiency is very large. So heliostat is nowadays used very frequently. But that time he designed it. He never gave up that, oh, I don't have source, how can I do experiment, things like that. So he designed his own heliostat and pointed the sunlight so that it comes and falls onto particular liquid. Of course, he has designed a collimator and spectrograph for himself, and the detector was naked eye. So he was trying to see whether there is a change in color which is appearing when the light is getting scattered from this particular liquid. So he was mostly using organic liquids. So first thing, and that is the beauty of this particular experiment, was that Einstein and Somochulowski said, I have diverted something. So Einstein and Somochulowski said, they said that during this critical opulence, what is happening? As far as there is any phase transition which is taking place, so there is a large amount of fluctuation in density. We all know in our real life also, whenever we take a phase change from, let us say, from student life to your professional life, there are large fluctuations. You have to go to different cities, your lifestyle will completely change and things like that. Similarly, in any liquid or gas, when it is going to a phase transition, there is a large change in density which is taking place. If there is a large change in density which is taking place, means what? There is a large change in refractive index which is taking place. If there is a large change in refractive index, now all you may be very easily understand that there will be large amount of scattering that is taking place. And a liquid which is transparent, around phase transition, you will find that it becomes a very blur liquid. Blur means what? It is no longer that much transparent, very semi-transparent, hardly transparent. And that is happening because of this. And Einstein and Somochulowski has suggested that there is a 1 over lambda to the power 4 relation with this scattering. That is, and this particular part was picked up by Rayleigh and of course by Raman also, that this scattering is proportional to 1 over lambda to the power 4, and that is what Rayleigh has used in order to explain the color of the sea, isn't it? Color of the sky. Rayleigh has first defined what is the color of sky, why it is blue, because blue is the, out of 3 primary colors, it has the smallest lambda, and because it is getting scattered 1 over lambda to the power 4, so blue, so the sky appears blue. And then he said that sea appears blue because sea is nothing but merely a reflection of the sky. Raman once was traveling by sea to attend a conference to Europe, found that this particular hypothesis is totally wrong. It is not correct. Why? Because he observed sea during daytime, nighttime, evening, and all that things. Professor Venkatraghavan, who has written a very good biography of Raman, said that like a doctor always carries his stethoscope, similarly Raman used to carry his spectroscope with him. And on the sea, he used to observe the color of the sea. And then he is also recalled the expression of Einstein and Somochulowski that there is a 1 over lambda to the power 4 point of a thing. And then he immediately given his explanation for sea color also, that like gases in atmosphere scatters as 1 over lambda to the power 4, similarly water in sea also scatters, and it is also proportional to 1 over lambda to the power 4, and that is why sea generally, wherever it is mostly free of impurities or flora and fauna, appears blue in color. So Raman was so keen in finding out this type of a cues, and then he was very much interested in finding out how this scattering process is happening in different liquids. So immediately once he came back to Kolkata, he started doing experiments, and in these experiments mostly he was finding out organic liquids and other liquids. And the one instruction he gave to the students that these liquids should be extremely pure, because now all you must be appreciating that unless the liquid is highly pure, you will not be able to find the exact cause for scattering, isn't it? And then in this particular cause also, what they observed is that this liquid is, there is a small amount of change in color which is taking place. Of course, they have indigenously designed some filters also, glass filters and uranium filters also, because we all know in order to find different color, first of all, the sunlight has to be single colored. To make it single colored, he used different glass filters and uranium glass filters and things like that. And I will not go into details of that. It is easy. Now we all know that goggles have different type of a glass. If you find that only that color will be transparent and things like that. So this is how he used his particular part in doing things. in doing experiments. And what he observed is there is a slight change in color which is taking place. The so student has reported them, and the Raman then in the afternoon did the same experiment during February, and he found out that yes, it is over there. And then Raman suspected that it can be fluorescence also. We all know what is fluorescence. Phosphorescence and fluorescence you have all studied, where whatever may be the incident color of the light or white light you shine into it, depending on the band gap of that fluorescence or phosphorescence material, we always get that kind of a color which is taking place. So how to distinguish between fluorescence and Raman scattering, which is a scattering process, and fluorescence or phosphorescence is what? It is absorption and re-emission process, isn't it? So the two processes are slightly different. One is a scattering process, the other one is a absorption and then re-emission process, where there is always a radiation-less emission which is taking place. Because this fluorescence process is a radiation and emission process, so what people have observed that it should be isotropic. So there should not be any polarization effects which are taking place in this particular part which is over there. And Raman used this particular property only to distinguish his particular phenomena, and he immediately ordered students to find out the polarization characteristics. And we all know calcite crystals and other things can be used in order to find out the polarization characteristics of the light. So Raman was so thrilled that particular day that he said that we made a discovery. Once he established that there are polarization characteristics to the scattered light with a different color, he was very sure that it was not a fluorescence, because earlier they were reporting that time saying inelastic scattering was very difficult, because I will just show a few slides where I will show that why it is difficult. And then he was excited, because see, in a fluorescence, as I told you, that there should not be any polarization characteristics, and this polarization characteristics only we also used in order to find out this femtometer displacement in materials. And I will show you some of the slides. So now let me share the slides. I think I am not made the presenter, so somebody should make me the presenter. So sorry, without presenter, I could speak for more than 20 minutes or something. So please make me presenter. Yeah, thank you. I think these slides are visible to you all. Okay, just for the students, you can go to this website www.csr.res.in, and you will get all the facilities which you can use free of cost, and you can propose experiments using all these things. And believe me, we have fantastic facilities, and the uniqueness of our institute is that all our facilities are always working. Almost 90+% facilities are always working, and that is the purpose and of establishing this center, because UGC has recognized in 1990, at that particular time at least, that universities, though they may get facilities, it is difficult to maintain these facilities over there, because generally these facilities are bought in university through project, and once the project money is over, it is difficult to sustain the facilities. And for any facility which is costing crore, 2 crore, 3 crore, you always require some spares and maintenance and things like that. Let us come back to this particular topic of discovery of Raman effect. And so I think I have already explained you most of the things, and this Ramanathan and things like that. So that time also they used this weak fluorescence was discovered. So they were not sure that it is inelastically scattered. Once they established that it is nothing but they have a polarization characteristics, Raman was very these things. And then Raman was so confident that he could discover a quantum effect in light scattering, that when he needed funds to purchase a spectrograph, because now he requires some spectrographs and X-ray films, or kind of a photographic film, not X-ray films, photographic films to record the spectra. So he wrote to industrialist G.D. Birla that if I have it, please fund me. If I have it, I think I can get a Nobel Prize for you. So that was the confidence of Raman at that particular time. Second thing is he was not shy of his language or his turban and things like that. When he went to Britain, he was not shy of his turban. He kept his turban over there, and he was immediately recognized by many other fellows that he must be C.V. Raman because from his turban itself. So that was the confidence level he had in particular time. Okay, so these are some of the diary notes of his student Krishnan, and I will just go to the last one because I want to show some results over there before my time is over for the lecture. So Raman examined the scattered tract with a direct vision spectroscope. This direct vision spectroscope means your eye is your detector, and separated regions between them, and a clear demonstration of change of wavelength in scattering. So this was about this. The only point which I would like to know is I would like to this thing that Raman was aware of lack of ideas in university system. University means all researchers at that particular time. I'm sure nowadays I'm very optimistic about young generation of today's in universities which are creating a lot of startups and things like that. So they are also quite this thing, and today's workshop, that is why is very apt in this thing that putting up a new ideas for startup or something like that. So at that time he wrote in 1970 that even a man of sensitivity and imagination can become bound and unfree when he has to falsify his feelings. If he forces himself to say that he likes what he dislikes and that he believes what he does not believe, then he will have to pay the price in that his spontaneous and his creative faculties would dry up. And that is why I'm again and again insisting all the young fellows, be bold, stick to your ideas, be open for the discussion. If you feel that you are wrong, accept it and go ahead with it. So this was the thing with C.V. Raman. This is the humble spectrograph using which he has invented the Raman effect. You can see this from here. They used to see this is a collimator and sunlight was their source. Later on, they put a photographic film over here to record the spectra. So the first spectra is this CCl4. You can see. So on both sides, you can see the lines are very well separated from the Rayleigh line, which is over there. And so this was the first one which is reported over there. So let me now, I will not start this particular talk because I believe I don't have more than 5 or 7 minutes or something. But again, I will tell you that inelastic scattering, which Raman has discovered, showed that if I have an incident green color, then my scattered color should be slightly different. And what we used is this, that the polarizability should be non-zero because of the vibrational direction. So whenever there is a vibrational which is taking place into any particular molecule, then the polarizability also oscillates. And this change in polarizability is giving Raman spectroscopy, isn't it? If you recall your expression, which even Einstein and Smolowski has given for critical opulence, there also you will find that the scattering cross section is related with what? It is related with what? It is related with refractive index, and we all know that refractive index is again related with what? It is related with polarizability. So again and again this is coming. All these relations are clear, and that is what we also use. So we said, or so we argued that if this polarizability is changing because of this particular vibration which is taking place, now vibration can take place in several directions. It can be bending vibration, it can be stretching vibration and things like that. So we argued, we put forth this argument that if it is a stretching vibration in this particular direction, then my polarizability will change in this particular direction only. And that is what is the meaning of Raman tensor. And so we use this knowledge of Raman tensor, that which Raman tensor is going to give me the information if the vibration is along this particular point. So what argument we put forward? That if my interatomic distance is going to change by a very small amount, 10 to the power, so when we call about femtometer scale, it is 10 to the power minus 15 of a meter or 10 to the power minus 5 of a Armstrong. So it is a size of a nucleus. And generally in scattering process, if you recall, that people generally neglect the nucleus because they say that nucleus is very small compared to the atom, isn't it? We all neglect that particular contribution. But what we proposed, and we actually read a paper by D.A. Long which was published in 1956 or something, where they have shown that very small change in interatomic distance can give me asymptotic change in polarizability. So what we did along with my students is that we then managed to focus on particular polarizability change which is taking place in a particular direction. So we targeted few Raman tensors and analyzed them, and we could establish that particular point. So before I go into it, I will just show that few results to you, those who are interested, and then I will show some popular results also for the sake of so many people who are, or students who are present over there. So just I would like to flash this particular transparency where what we are talking about is shown that if I choose a polarizability component using these relations, that is, if I choose this YY or something like that, which means that if there is any small change in polarizability across Y, I will be able to know, I will be able to see change in this particular part. And Raman intensity is nothing but proportional to the square of this Raman tensor element. And therefore, first of all, we have to find out the values of Raman tensor elements, and to choose a Raman tensor element which is attached with a particular vibrational mode, which is going to give us this type of information. So because most of the students are well known or with BATIO3, so I will just show you some example on BATIO3. So this is what is the work which we were doing. And those who are interested, so we have published these 3 papers. The first one is, of course, where we have solved the very long-standing question on CUO, that why CUO shows ferroelectricity. CUO should not show ferroelectricity, it is anti-ferromagnetic, but it showed ferroelectricity below 230 K. And for the first time, we showed this particular part, that it is the small, that is femtometer scale displacement of CU out of its symmetry, which is giving, making it non-centrosymmetric, and the system becomes ferroelectric in nature. So I will take this example on BATIO3 because I believe it is easy to understand in BATIO3 compared to CUO. And of course, we showed the same thing in NDGO3 also, which all these papers we have published in last year itself, all the 3 papers. And this is a recent one. This is just to establish our hypothesis or our new methodology. So we all know that BATIO3 is a tetragonal system at room temperature, and from cubic to tetragonal it shows some transition. And it goes to orthorhombic around 270 K or 276 K or something like that. And below 130 or something, it is rhomboidal. So all these phases are shown by this BATIO3. And we all know that in BATIO3, in a tetragonal phase, the center of this titanium ion is slightly displaced, and that is why it is non-centrosymmetric. And so what we expected, that there should be a polarizability change in this particular direction only. You can see if my atom is going from center of symmetry to non-centrosymmetry, my polarizability should be seen in this particular direction, which is my C-axis. We all know that the atom moves along C-axis or something like that. Similarly, we put forth this particular part, when it is going to orthorhombic, then I must have a polarizability change which is not only along C, but along some other axis also, which is A in this particular case also. And when it goes to rhombohedral, please note, in case of a rhombohedral, because the atom goes non-symmetric along 111 direction, so the polarizability changes in all directions. So whatever may be the geometry I consider for taking the Raman spectra, we have put this particular part, that whatever may be the geometry I take, I must see a change in intensity which is taking place, because there is a change in polarizability which is taking place when I am in rhombohedral phase. But I will be able to notice this change only if I scan my Raman intensity along this direction using polarized Raman spectroscopy. While as in this case, also it should be smaller compared to this, because now I have 2 components which are involved. And you see these beautiful results you can see. So I have taken 2 directions. Unfortunately, I don't have time at present to explain you in detail, but we can very easily do that particular part. And you can see in these 2, both the geometries, the rhombohedral showed systematic decrease in intensity as I am decreasing the temperature. And you see the beauty of this experiment. The change is also same. That is from 30, nearly 30 to say 90 or something. And here also, if you see, the change is from 30 to nearly 90 odd. So that is establishing our hypothesis that whatever, because the polarizability is changing uniformly in all directions, I must get a change. And you see in tetragonal, as I told you, when we measure in this particular direction, that is when we chose a particular phonon, which is TO2 phonon, which has a vibrational eigenvectors along C direction, I get the maximum change. When I am orthogonal to it, I don't get any change. Rather, this change which is there is because there is a small disorder in domain structure of BATO3. But you see beautifully again, as I told you, because polarizability I am measuring along C, so tetragonal should show the highest slope, and the slope of this tetragonal, where it is changing the intensity, is highest over here. Compared to that, orthorhombic is slightly lower, and in rhombohedral it is slightly lower. Even we did qualitative and quantitative analysis also, and it established the same results. So that is the beauty of these experiments. So these are the Raman tensors which were involved in this particular part. I will not go into details of this particular part, but we actually showed one-to-one correspondence with X-ray also. So this is the X-ray results, not by our group, but by literature. And we showed that how this change which is taking place in Wyckoff position or something, which is giving me non-centrosymmetricity in Raman, is again on third decimal place or something at 150 Kelvin interval or something. So if I go to 10 Kelvin, I will be able to go to fourth decimal place or 5 decimal place in Raman, and we are able to see this. And you can see phase transitions are also coming over there. Okay. So just before I end my talk, I will give you, because this was our examples which I have given, that Raman is nowadays very important in nanoparticles and many other things. Because of time restriction, I am not stopping there, but these are some of the popular things. It's not that Raman is used only in physics and chemistry and things like that. It is even used in forensic science. Like you can see how you can find out whether the document is forged or not. Forged documents mean what? Somebody has taken signature on a stamp paper and then printed something over it, isn't it? Or that document is already typed and then the person has read it completely, त्यांनी नीट वाचलंय आपल्या होशो हवासमध्ये, आहे ना. अदालती जी लँग्वेज आहे ती खूपच छान असते. मी आपल्या होशो हवासमध्ये याच्यावर साईन करतोय, तर त्या होशो हवासमध्ये त्यांनी साईन केलंय की बिना होशो हवासमध्ये साईन केलंय, ते सुद्धा आपण रामनने पाहू शकतो. सो व्हॉट पीपल डू इज दे हॅव टेकन अ रामन मॅपिंग ऑफ इट. रामन मॅपिंग म्हणजे खूप सगळे रामन स्पेक्ट्रा पॉईंट बाय पॉईंट बाय पॉईंट मेजर केले गेलेले त्याच्यामध्ये. अँड नाऊ यू कॅन सी that your ball pen ink that evaluated Raman spectra of paper, you can see paper gives this type of a Raman signature, printer ink gives yellow type of a signature, sorry, and this blue Raman spectra is nothing but ballpoint ink like a signature. So now you deconvolute this using some computer routine or something like that by doing Raman mapping, and nowadays softwares are available inbuilt in Raman spectrometers itself, where you can plot actually where is the ballpoint ink, where is the printer ink, and where is the paper. So you can see here clearly it is established that this is not a forged document, because my this printer ink is below my ballpoint ink. If it would have been printed after the signature, naturally I would have got a lot of printer toner over the signature, isn't it? But in this case, it is hardly seen over there. So this establishes that this document is not forged, but it was a genuine document. Similarly, we can analyze many of these particular oils also. See, this is also there. Now, see, we all know that olive oil is very costly. So maybe some person can mix palm oil or other things into it. So that is quite possible, because olive oil is naturally 700, 800. A very pure virgin olive oil is very, very costly, isn't it? At least even if it is not virgin, then it is also costly. It is 400, 500 per liter, while a sunflower and all nowadays is 150 or maybe 175 per liter, and palm oil is below 100 or something like that. So you can see here that different oils gives different signature. This, if you concentrate on this particular part, you can see the relationship between this intensity of these two particular modes is slightly different. So you can generate a mathematical model by doing number of scans, Raman scans, and identify whether there is a adulteration in olive oil or even in our general sunflower oil with the palm oil and other things also. And this is the blended. So you can see, and a blend of the two oils. So you can see here, this is the, I think this is the pure olive oil. So that is the blue. So the intensity, this one is smaller compared to this, while as here, which is sunflower oil, the two are comparable. So in this blended oil, you can see slightly the change in the ratio of these two particular oils. So there are these small distinctions which are over there, and researchers can come up with models to solve this type of problems also. I think with this, I think it's a powerful technique to get photon spectrum of solids, liquids, gases, and we have shown many this particular part. Before I end, I thank my students. These are my students who have very actively participated in these experiments with me. And of course, I also thank all my users and things like that. And before I end, let me say that every brilliant experiment is like every great work of art. Starts with an act of imagination. So imagination is very important, which is what Raman has shown, and that is what is scientific temperament, because scientific temperament is nothing but imagining something and then acting onto it to make it a real life phenomena. Thank you very much once again for giving me this opportunity to share some of our work and thought on Science Day. Thanks a lot. Namaskar. मला आवाज नाही ऐकू येते. I'm not able to hear. Okay. Yeah.
Sir,
Now it is there.
Yes, okay, thank you. So on behalf of organizing committee, I thank you, sir, for providing your gracious presence to join us today on online platform. We are also grateful to you, sir, for sharing your knowledge, thoughts, and experience with us today. And also thank you for assuring us that we can use the facilities at your end. RTM Nagpur University would like to felicitate you, sir, on the occasion. On behalf of RTM Nagpur University, I would like to read out the felicitation message. The message is displayed over here. It's a great pleasure and honor to felicitate Dr. Vasant Sathe on occasion of National Science Day 2022 for new endeavor as Director UGC DAE CSR New Indore and Achievement Medal 2021 of Materials Research Society of India. Your tenure as Director in UGC DAE CSR Indore is enriching scientific research collaboration between Indian universities and UGC DAE Consortium for Scientific Research. The mega and advanced research facilities of DAE becomes easily accessible for research communities of Indian universities. Your research contribution in Raman spectroscopy-based experimentations for studies of various in situ scientific phenomena are integrated to develop various indigenous technologies. Your outstanding contribution in understanding ferroelectric phase in CUO by using polarized Raman scattering in detecting ionic displacement at the femtoscale explore new directions of Raman spectroscopy for investigations of dynamics of nanotechnologies and nano devices. On behalf of Rashtrasanta Tukadoji Maharaj, Nagpur University, accept our felicitation message for your outstanding research contribution in Raman spectroscopy on occasion of National Science Day.
Thank you. Dhanyavad.
Thank you, sir.
खूप आभार.
We are privileged to have with us President of today's program, Honorable Dr. Subhash Chaudhary, Vice Chancellor, RTM Nagpur University, the man of distinct vision and a fountainhead of illuminating ideas, an idol of knowledge and experience and inspiration to all of us. May I request Honorable Subhash Chaudhary, sir, for the presidential speech. Please, sir.
माता सरस्वती विद्येची देवता वंदनीय राष्ट्रसंत तुकडोजी महाराज यांना अभिवादन करीत आपण सर्वांना या आजच्या नॅशनल सायन्स डे निमित्त शुभेच्छा. First of all, I would like to bring you out of the Raman effect first. So definitely, C.V. Raman has had a great work on the Raman effect, and he discovered on 28th of February 1928. But we observe that day, 28th February as the National Science Day, and every year a theme is floated. I would not discuss on the science, but I would like to have some focus on the theme of this National Day. If you see the theme, that is integrated approach in science and technology for sustainable future. Two words are very important, that is integrated and sustainable future. It has a deep meaning, and one must think about these two phrases, two words, or two focused domain. We started with university song, that is या भारतात बंधुभाव नित्य वसुदे देवरची असादे. The song itself starts with the integration of people. And unless there is integration, one cannot achieve anything. And that theme is here. And integration means there are different meaning involved in that. That is interdisciplinary, multidisciplinary, or come together. That is collection. Integration means collection. In mathematical, one can very easily understand. That is the addition or collection of different domains. And that's why on this Science Day, it is appealed that we must integrate not only science domains or science subjects, but for all subjects. Either it is of humanities, either it is of commerce and management, or it may be of science and technology. Whatever are the subjects, whatever are the knowledges, whatever are the ideas, all are to be integrated. For what? For sustainable future. Sustainable future itself is a very important, we can say, expression that everyone must understand and must take care about that. The word future itself indicates that for coming future, one has to be very careful in using any technology or developing any technology or going in research or adopting any technology. And in all, if you see, there is one center, that is nature. If nature is there, then human being or plant and animals will be there. अगर nature ही नहीं रहा तो हम कोई नहीं रहेंगे. And for the sustainable nature, we have to think about the proper technology, proper, we can say, sustainable approach or process so that the future can be a sustainable future. Development, whenever there is a development, definitely there would be some adverse effect in adopting anything. But development should not be at the cost of nature. That is the most required, or that is the duty of human being, to maintain that nature. You see, if any product comes in the nature, and if it does not finish up, or it does not disintegrate, or if it does not get vanished, then it may create a lot of problem in the nature. And the cycle should be completed. The nature's very much property or phenomena is that the cycle should be completed. Anything comes in the nature, it should finish after the fixed timing or after one complete cycle. And that's why it must deteriorate. Everything should go again back to the nature. That is the philosophy, that is the nature's property. If you see, even if you take the steel, loha, if from iron ore it is made from the iron ore, and if it comes in the nature, then again nature impact on that. The nature starts deterioration by corrosion effect. That means iron ferric oxide, the ore is ferric oxide, gets converted into ferrous, and then again from carbon dioxide, absorbing carbon dioxide or oxide from the nature, it again gets converted into ferric oxide. That is again the corrosion, which is the ferric oxide, will again go back to nature. Even our human being also. Once we take birth, after all we go back again with the nature. So that cycle must be completed. And whenever we introduce, whenever we design a process, whenever we design or develop any product, then the care must be taken. It should be finished at some time or after some time. That is very much important. And for that, we must take care about all this sustenance of the nature. And that's why there is one word, that is appropriate technology, appropriate science. No doubt, the sustainability or sustainable word is the broader word, and appropriate is complementary to that. Appropriate means what? Which is very much relevant to that local region, or that region. It is relevant to the people of that region. It is relevant to the resources available in that region. And whenever we need to develop any technology, it should be acceptable by those people. And that's why that sustainability will be maintained there. Any product should be designed for the local people, by the local people, and through the resources of the local area. And that will be sustainable. And that cycle must be completed. Otherwise, what will happen? The unemployment will increase, definitely, because they will not be used. And that's why everything, every activity, every process, every research, every concept should be centrally focused with the sustainability. And that's why sustainability, to have the sustainability, to keep the nature at place, it is very much essential to understand some concept. Because we are living being, human being, and we always try to live our life with all duties and our responsibilities. We earn money for our better life, comfortable life, and quality life. And whenever we earn, we go through the economy. There are different types of economy, because development comes with economy. If you want to develop the country, or if you want to show that our area is more developed, then economy per head capita should be increased. So there are different types of economy, and that we must understand which we should choose. हर इंसान जीने के लिए अलग अलग रास्ते अपनाता है. Which one we should choose? There is one book written by J.C. Kumarappa, that is Economy of Permanence. And that permanence word itself is the sustainability word. Comes in the domain of sustainability. The first economy is the tiger economy. That is parasitic economy. टाइगर जीता है किसी को मार के, किल्ड, उसका तो चल जाता है, लेकिन सोर्स खत्म हो गया. दैट इज वन इकोनॉमी टू जीने के लिए, दैट इज वन. अनदर इज मंकी इकोनॉमी. These words are just the synonyms to the word used in English. Another is monkey economy. क्या करता है वो छीन लेता है और खा लेता है, लेकिन सोर्स को खत्म नहीं करता. That way is also the way of living life. Third is the economy of enterprise. मतलब हम अपना काम करते हैं, उतना कमा लेते हैं, उतनी जितना हमको लगता उतना. नेचर का जो भी काम है, खेती वाला खेती कर लेता हो, बर्ड्स अपने आसपास घूमते हैं, खाते हैं, जीते हैं, लेकिन सब करते वक्त ये भी नेचर भी बैलेंस करते हैं. फॉर एग्जाम्पल बटरफ्लाई, they move from one flower to another flower, but at the same time they are doing the service, that they are maintaining the nature. Pollen जो भी है grains इधर से उधर transfer करना, so that the nature cycle will be completed. वो भी, that also helps to complete the cycle of nature. क्योंकि अगर birds नहीं होते, flowers नहीं होते, तो शायद ये pollination effect या बाकी का जो है cycle plants का, वो complete नहीं होता. So it is also one of the important part. And the next is the economy of aggregation, that is just as a honeybee economics. Generally they work for the group. अपने लिए काम नहीं करेंगे, ग्रुप के लिए काम करते हैं. They collect the honey and store at one comb. And they collect for the group only. That is one economy. They does not have their own agenda or their own we can say self need. And the last one is the mother economy. Mother economy means selfless. The mother economy tries to develop their child from birth to get themselves at their own position or at their own till they share their responsibility at their own. Mother works for the development of their next future generation, and they work without any expectation from their child. And that economy is required, because we have to think about the next generation. And if we don't think the future of next generation, definitely we will, the future generation will curse us that what हमारे forefather ने क्या करके रखा, ये हाल बना के रखा. So this should not happen. We have to protect the nature, and for that everyone should work for that. And that's why this is integration approach. And for to do this, जो हमको एक दूसरे का जो चाहिए साथ, या एक दूसरे के प्रति हमारा जो एक स्पिरिट चाहिए इंटीग्रिटी का, ये तभी आएगा when we live together, when our curriculum is also of integrated nature, that is interdisciplinary or multidisciplinary. Fortunately, university has entered for developing the curriculum in integrated or multidisciplinary nature. That is the things which we start from home also. घर भी अगर मान लो, now we are living in the nucleus family, but integrated family, joint family will give you more effect or sustainability. You may get some buffer support in your worst days or critical days. So that is the concept. That's why I'm saying these two are very important: integrity, integration, and sustainability. These are, one must think on these two things. Then, and that's why if we live in integrated way, if we work in integrated way, if we do the research in integrated way, then definitely a beautiful or sustainable circumstances or atmosphere will be created. अभी रमन इफेक्ट के बारे में आपको बताया. So many times that color word came in picture. There are 7 basic colors in the nature. Basic नहीं, लेकिन 7 colors are there. And what is integrated color? That is white. 7 कलर मिलके एक वाइट कलर बनता है. इसमें से एक भी कलर थोड़ा सा भी कम ज्यादा हो तो शेड बदल जाता है. और जिसका कोई कलर नहीं होता वो ब्लैक है. अगर हम ये इंटीग्रेटेड नहीं रहे तो एक दिन हम ब्लैक हो जाएंगे, डार्क हो जाएगा. सो दैट्स व्हाई our approach should be of integrated and sustainable. Then only we can survive. Our nature will be in position, and जब तक हमने nature को maintain करेंगे, nature will maintain us. That is the awareness nowadays to maintain the nature. Then regarding the startup also, it has been mentioned regarding startup. Startup is also the activity of integrated nature. कहते हैं ना कि सारे दुनिया का ज्ञान अपने दिमाग में भरा हुआ है. The complete knowledge is in our mind. ठीक है, हम कब एक्सप्लोर करते हैं, कितना एक्सप्लोर करते हैं, इस पे डिपेंड है. To remove the curtain of unknownness, that is our darkness, is nothing but education. किसी एक में हमने डीपली चले गए तो शायद रिसर्च हमारा हो पाएगा, या हम मल्टीपल डायरेक्शन में गए तो रिसर्च हो पाएगा. कोई भी रिसर्च अगर हो गया, अभी जो सेंटेंस साडे साहब ने कहा कि आइडिया आती कहाँ से? हमारे दिमाग में. अभी कुछ दिनों पहले हमारा इनोवेशन के बारे में एक डिस्कशन हुआ था. देयर वन ऑफ द गेस्ट हैज़ वेरी क्लियरली सेड कि आज अगर हमारे दिमाग में कोई आइडिया आई तो हो सकता साल, 2 साल, 10 साल, 15 साल, 20 साल के बाद वो प्रोडक्ट जरूर आएगा. समय लग सकता है, बट पहला जन्म किसने लिया उस प्रोडक्ट का, आइडिया का? हमारे दिमाग ने लिया. और वो रिसर्च भी कौन करता है, प्रोडक्ट भी कौन डेवलप करता है? हमारे दिमाग से ही आता है. ईच एंड एवरी नॉलेज, एवरी प्रोसेस इज हियर इन दिस. एंड नेचर इज द बिगेस्ट लेबोरेटरी. नेचर इज द बिगेस्ट एग्जीबिशन ऑफ द साइंस, जिससे हम सारी चीज सीख रहे हैं, सब देख रहे हैं. our body itself is the big laboratory or the science model. बहुत सारी चीजें तो हमने अभी रिसर्च किया भी नहीं है, नेचर में इतना सारा है. स्टिल many more things are to be explored and discovered. इमेजिन करो, एक एक सेल, एक एक पार्ट ऑफ द बॉडी कितना बढ़िया फंक्शन करता है. और ये सारी चीजें हम धीरे धीरे उसके डीप तक जा रहे हैं. उसका डिटेल्स या उसके जो साइंटिफिक रीजन है, साइंटिफिक और बाकी जो प्रोसेस है, वो सब दैट वी आर ट्राइंग टू गेट इट. बट साइंस पहले भी था, मतलब ये नेचर में पहले भी था. इवन आपको पता भी है कि चाहे आप आइंस्टाइन का उदाहरण ले लीजिए या फिर न्यूटन का एग्जांपल ले लीजिए. हमें कहा जाता है कि एप्पल नीचे गिर रहा था तो उसने ग्रेविटेशनल फोर्स डेवलप किया. तो ग्रेविटेशनल फोर्स उसके पहले नहीं था उसके पहले भी था. एप्पल नीचे ही गिरता था, ऊपर नहीं जाता था, साइड में भी नहीं जाता था. वो डीपली उसने थिंक किया. देन समथिंग केम आउट फ्रॉम हिज माइंड दैट दिस इज द कंसेप्ट. So nature itself is the biggest laboratory and everything is in nature, and from nature also we are learning many more things, and that's why we have to protect the nature. क्योंकि नेचर ही हमको बचाएगा, नेचर ही हमको सिखाएगा और नेचर ही हमको बढ़ाएगा. And that's why for future generation, we should not destroy by any product. कुछ भी हमने product निकाला, if it is dangerous to the nature, then definitely something will happen. And nature will always give the anti-mother's treatment to us. And we may come across many more problems in our life. And for that also, it is very much essential that every human being should take care about the sustainable future. And for that, we must be integrated. And this is the spirit and this is the theme of this today's day, which we generally observe as a national day. And I hope everyone would keep this theme in mind to move ahead, to lead ahead. Thank you. Thank you very much.
Thank you, sir. Sir has explained today in a simple language the detailed meaning of the theme of National Science Day and guided us for the same. Thank you, sir, for the enthralling and magnificent words and enlightening us on the occasion. Now I call upon Dr. Samaya Humne from Geology Department to propose vote of thanks.
Thank you, ma'am. Very pleasant good afternoon to the dignitaries on the dais, off the dais, eminent scientists, faculties of various departments, budding scientists, researchers, and student friends. Myself, on behalf of Organizing Committee of National Science Day 2022, take this opportunity with immense gratitude to thank Honorable Vice Chancellor Dr. Subhash Chaudhary, sir, for giving his precious time to grace this inaugural function and for his presidential address. My heartfelt thanks are also to Dr. Vasant Sathe, Center Director, Indore, UGC DAE Consortium of Scientific Research, for presenting his keynote address and for sharing a bit of his vast knowledge with us today. My sincere thanks to Dr. Rajesh Singh, Director IL, for his presence, scientific ideas, and support. My deep sense of gratitude are also due to Dr. Prashant Maheshwari, Dean, Faculty of Science and Technology, RTM Nagpur University, for giving his time to make his presence in today's inaugural function. My sincere thanks to Professor P.B. Khedekar, HOD Department of Pharmaceutical Sciences, for his logistic support and providing this hall to carry out this function. An event like this cannot happen overnight. The wheels start rolling weeks ago and required planning and perfect execution, and we are fortunate enough to be backed up by Dr. Rajesh Singh, Director IL, Dr. Smita Acharya, Director IQAC, Dr. Veena Bilgamwar, and Dr. Vijay Tangde, Coordinator of National Science Day 2022. I take this opportunity to thank and acknowledge the untiring efforts by entire team of National Science Day 2022, Professor Nitin Dungarwar sir, Dr. Abhay Deshmukh, Secretary, Dr. Rupesh Badere, Treasurer, Dr. Aarti Shanware, Dr. Apurna Samudra, Dr. Dheeraj Kadam, Dr. Sanyukta Thorat, Dr. Ravi Khangai, Dr. Satyendra Prasad, Dr. Prajakta Nande, Dr. Umesh Palkundiwar, Dr. Rita Vaddatiwar ma'am, Dr. Archana Moon, Dr. Rajesh Hugale, Dr. Payal Thavre, and Dr. Shubhda Zambulkar. It's my pleasure to thank all head of the department, of all faculties of our university for their presence and for encouraging their students to participate in the competitions today. My deepest thanks are to all the participants who have shown their keen interest in participating in startup ideas and presentation and self-designed product advertising competitions. My sincere thanks are also to all the student volunteers who are helping the organizers in making the event grand success. Last but not the least, I like to thank each and everyone who helped us directly or indirectly in making the event successful. Thank you.
May I now request Honorable Dr. Subhash Chaudhary sir to proceed for the inauguration of self-designed product advertising competition and interdepartmental exhibition competition. I request the participants of self-designed product competition to remain present at their respective stalls. Simultaneously, we are going to start with the startup idea competition here in the auditorium itself. The participants of Startup Idea competition should remain present here only. And now I hand over this podium to Aarti Shanware ma'am for further proceedings.
which he announced on this day in 1928. This day is celebrated to popularize science and its applications among college students, to foster the spirit of scientific temperament, and to stimulate their minds to explore new frontiers of science and technology. On this very special occasion of National Science Day 2022, bearing the theme of National Science Day of this year, is integrated approach in science and technology for a sustainable future, which is being organized by Internal Quality Assurance Cell of our Rashtrasanta Tukadoji Maharaj Nagpur University, Nagpur, which is being catalyzed and supported by Rajiv Gandhi Science and Technology Commission, Government of Maharashtra, and Board of Innovation, Incubation and Linkages of our own university. I welcome all of you, distinguished judges. Professor Veena Belgamwar, Madam, the convener of today's event, Professor Prashant Maheshwari, Dean, Faculty of Science and Technology, heads of postgraduate teaching departments of UDPS, RTMNU, Nagpur, the distinguished juries for today's competitions, research scholars, UG and PG students, other dignitaries seated off the dais, my learned colleagues at all university departments of RTMNU, members of the press, if present any, delegates, and dear student friends. I extend my warm welcome to this august gathering once again. We consider it as our honor and proud privilege to have with us an eminent personality, Dr. Aarti Savji Madam, who was former director, Institute of Science, Nagpur, and professor of botany. Now I would like to invite Dr. Archana Moon, from Department of Biochemistry to welcome our eminent judge, Professor Aarti Savji Madam, by offering certificate, memento, and sapling as a token of our gratitude.